Guys, and welcome back. So in this video, we are going to learn about a new type of sequence. So the last couple of weeks, we've been really looking at arithmetic sequences. And this week, we're going to start looking at geometric sequences and looking at how they're different. And we'll do a lot of the same things we've been doing in the last few weeks with arithmetic, but now we're going to do them with geometric and do a little bit of comparison. So students will be able to, students will be able to identify geometric sequences and write a recursive rule. You will be able to find a pattern and determine if the pattern is geometric, and then use this information to write a recursive rule. So we are actually going to skip the first page and go right to the back. We'll do that first page tomorrow in class, or Monday in class rather. But for this first part, we're just going to go ahead and fill in these notes. So a geometric sequence is just a sequence that multiplies by the same amount each time and therefore has a common ratio. And that common ratio we will let be R. Just like in arithmetic, we had a common difference that was D, and geometric will have a common ratio of which is R. And it's called a ratio because the opposite of multiplying is dividing, and dividing is finding a ratio. Just like with arithmetic, we were adding, so we had a common difference because difference is the opposite of adding. You can think about it, you'll be able to find your common ratio by dividing. Just like when we were doing arithmetic, we found our common difference by subtracting. So we're first going to find the next three terms in each sequence. We will identify the common ratio. So when we're looking at this, we see we're going 3, 6, 12, 24, and 48. If you can see that you're multiplying by 2, then you've found your common ratio. If not, remember you can always go to the side, and your common ratio will be R is equal to term 2 divided by term 1. You always take the second term and divide it by the first term. And it doesn't necessarily have to be exactly term 2. It's just the term after divided by the term before. So here we'll have R will be equal to 6 divided by 3, which is 2. So our common ratio is 2. Then you're just going to multiply everything by 2 to get to the next term. So 3 times 2, 6 times 2, 12 times 2, 24 times 2, and then 48 times 2 is 96. And then 96 times 2 is 192. And 192 times 2 is 384. So these numbers get bigger much quicker than our arithmetic sequences. Now let's jump down to number 8. While number 5 was an increasing sequence because our numbers were getting bigger, we can see our numbers are getting smaller. Thinking back to the definition we gave, geometric is always multiplying. So even though when we did arithmetic sequences, if it was going down, we just made a negative, we thought about a subtraction, and it worked. But with multiplication and division, it's a little bit different. So you might say, oh, well, look, 12 divided by 2 is 6, and 6 divided by 2 is 3. And that is great, but we don't want to say divides because we can't say that. We just want to give a number that is our common ratio. If we say it's 2, then that's going to imply that you're multiplying by 2. So we want to know what we can multiply by to get 6 from 12. And so you can think about it. If you do our little formula, term 2, 6 divided by 12, you'll end up getting 0.5 or 1/2. And so instead of giving a common ratio of divide by 2, what you want is to give a common ratio that is a fraction or decimal if it's going down. Because 12 times 1/2 is the same as 12 divided by 2. So then we get down to these fractions, because 12 divided by 2 is 6, 6 divided by 2 is 3, 3 divided by 2 is then 3/2, the dreaded fraction that nobody likes. But the beauty of these is that if you notice, 3/4 times 1/2, we are going to multiply all the numerators by 1. So all of my numerators will stay the same. And all my denominators will be multiplied by 2. So 4 times 2 gives me 8. So then when I multiply by 1/2 again, 3 times 1 is 3, and 8 times 2 is 16. And then multiplying by 1/2 again, 3 times 1 is 3, 16 times 2 is 32. So the fractions aren't quite as scary if you think about them as you're just going to then start multiplying your denominators by 2. The numerators will stay the same. Now I want for you to try and do number 6 on your own. So you should have found that your common ratio is 3, and then the next 3 terms will be 162, 486, and 1,458. So a recursive formula we defined in the last week, and we're just going to redefine it here. It's a formula that defines each term in a sequence based on the previous term. It must always state the initial term, or the starting term, along with the change. So in the last unit, or last week's, it has always been adding. Well, now we're going to throw in some multiplying. And it works exactly the same. So if we look at our example, our common difference here is timesing by 2, so our R is 2. So remembering back to our recursive rules way back when we started this, we're telling us that we're going to multiply by 2 starting at 8. So then when we transfer that into a recursive function, our next term will equal the previous term times 2 with the first term of 8. So let's work some examples. Given the recursive rule, write the first 5 terms of the sequence. So multiply by 5 and then starting at 1. So we are going to have 1 as our first term, and then we're going to start multiplying by 5 by 1. So 1 times 5 is 5, 5 times 5 is 25, 25 times 5 is 125, and 125 times 5 is 625. Now let's look at number 13. So it says that the next term will equal the previous term times 1/3 with a first term of 81. So 81 will go in our first blank. You always need to remember that multiplying by 1/3 is the same as dividing by 3. So while it says multiply by 1/3, you can still just divide by 3. So you would do 81 divided by 3 is 27. 27 divided by 3 is 9. 9 divided by 3 is 3, and 3 divided by 3 is 1. Remember that we can do that because if we have 81 over 1 times 1/3, 81 times 1 is 81, and then 1 times 3 is 3. And then remember at the beginning of the year, I said a fraction bar is just division. So that just means to do 81 divided by 3. You guys try number 12. So number 12 was telling you that the next term is the previous term times 3, the first term equal to 4. So you should have had 4, 12, 36, 108, and 324 for your answers. Going from the recursive rule to the terms is pretty easy. Now let's see what happens to write our recursive functions. Writing them, remember, will always have the same shell. So I'm going to come over here, and remember our shell was f of n is equal to f of n minus 1. And then we had plus d. Now it's going to be times r. And then we're going to have, I don't know why I want to write d. That's not right. F of whatever number will equal to some term. So remember that this will then be the common ratio. This will be the starting term number. And this will be the term number, or the term. Sorry, not the term number, just the term. Whatever that final term is. And that's what you'll use to write all of these. So when we look at number 15, we see that we have a first term of 3 and a common ratio of 2. This is the same as number 5 from the top. So when we write our recursive function, we will write our first part that's always the same. F of n is equal to f of n minus 1. And then we just need to say that we are going to multiply by 2 and that our first term is equal to 3. We also did the one like number 18 up at the top as well. So let's do that one. So we remember that our r was 1/2. So we have an r of 1/2. So when we write a recursive function, we will say f of n is equal to f of n minus 1 times 1/2 with a first term of 12. You try and do number 16. For number 16, you should have seen that your r value was 3. So you would have a recursive function that says the next term is the previous term times 3 with a first term that is 2. We will work the rest of these examples in class and I will answer any questions that you have. Hope to see you then.